So reviewing radicals, without your calculator, you take the number that is under the radical and you take it off to the side. And we're going to do upside down division. So you want to start with the smallest number. What is the smallest number that goes in 175? 5. And it goes in, 5 goes into 17 3 times with 2 left over. 5 goes into 25 5 times. What's the smallest number to go into 35? 5, which goes in 7 times. 7 is a prime number. You do not have to write 7 and 1. Stop at prime numbers. So what you do from here is you circle any pairs. How many, what does pair mean? Like how many are in a pair? 2. Okay, so do you see 2 of the same number?
Yes.
Yes. So when you do, you pull it out from under the radical. So you'd have 5 square root of 7 as your final answer. So whatever there are 2 of comes out of the radical. Whatever is not, whatever's all by itself goes inside of the radical. I'll explain why, and this is what you just did. Okay, what's 5 times 5? 25. So 25, you just said 25 times 7 is 175. Okay, we just did that. So what's the square root of 25? 5. So you took the square root of 25, took that out, and a 7 was left over. So that's realistically what you did. This is actually the way that I think of it. I don't do like this long method, but I'm also a math teacher. So it's okay to do upside down division. I do it with you guys, okay? We're going to do the second one as well. 294. What's the smallest number to go into 294?
2.
2. 2 goes into 2 once. 2 goes into 9 4 times with 1 left over. 2 goes into 14 7 times. So what's the smallest number to go into 147? 3. Here's how I know. What's 1 plus 4?
5.
5. What's 5 plus 7?
12.
12. Because the digits add up to 12, is 12 divisible by 3?
Yes.
Yes, so 147 is divisible by 3. That will be true for all numbers, even like huge ones. All right, so you have 147. How many times does 3 go into 14? 4 with 2 left over. How many times does 3 go into 27? 9. All right, and then what goes into 49?
7.
7 times. It's a good day. So do we have any pairs? 7. So the 7 comes out. And then we have 2 and 3 left. What do you think we do with the 2 and the 3? We multiply them when we leave them under. So 7 squared root of 6. The reason we're doing this is because, well, we're doing this in class today, but also even on your like assessments, you remember the first day of school? I think like 2 kids got them right, and they were international students. So this is the process that you use. Or some kids would do the upside down division, but then didn't know how to answer, like what the answer was. We're going to do number 3. You would do the same thing. What number is under the radical?
8.
8. So we're going to take the 8, do upside down division. What's the smallest number to go into 8?
2.
2. And it goes in 4 times. Smallest number to go into 4?
2.
2, and it goes in
2.
twice. So here is what we need to recognize. There's already a 4 here. Okay? So we're going to end up multiplying whatever we take out from under the radical. We're going to multiply it times the 4 that's already there. So we see a pair of 2's, so we take out one of them. All right, and then what's left under the radical? This 2. The reason I write 4 times 2 is just so everyone knows where I got the 8 from. The final answer is 8 square root of 2. Do we have any questions while we're doing this? Yes, sir.
So we have 2 pairs, and then you have, like, say you have 3 of the same number, take out 1 pair, and
So then the third would just stay under the radical.
I'm confused about the 4.
The 4?
Yeah,
The 4 was already here. So I just brought it down. Whenever there's a number already outside, you still keep it. You just multiply whatever comes out from the radical, you multiply them together. Did it actually answer your question, or are you just trying to get me to stop talking?
you asked me my question.
Okay. All right, 600 is the hardest one, and then you're going to do them by yourself. What's the smallest number to go in 600?
2.
Ooh, wow, that's ugly. I'll be over here. There we go. 2, and it goes in 300 times. Smallest number to go in 300,
2.
and it goes in, ooh. And it goes in 150. Smallest number to go in 150,
2.
2, and it goes in 75. Smallest number to go into 75,
3.
3. 7 plus 5 is 12. So it's not to say that you're wrong. Like, 5 definitely goes into 75. It's not that you would get the wrong numbers. It's that they wouldn't be right next to each other like these are now. Do you see how it progresses? Like here, we had 5, 5, 7. 2, 3, 7, 7. 2, 2, 2. Like, because I say the smallest number, your numbers will get larger and they'll be grouped together. So it's easier to see, hey, I have 2 2s. Hey, I have 2 of these. So that's why it's not necessarily that you would get the wrong answer. So it just, yours would be like, you'd have a 5, and then you would have a 15. So then you could divide by 3 or 5 again. But just your numbers wouldn't be together. That's all. How many times is 3 going to 75?
25.
25. And then what number goes into 25?
5.
5 and 5. So that's really the only reason I say the smallest number. It's really not a big deal if you don't. What groups do we have?
2 and 5.
2s and 5s. If we pull out more than one pair, what do you think we do with those numbers? Multiply them. So we'll do 2 times 5, we said, which is 10. All right, and then what numbers are left under the radical?
2 and 3.
2 and 3, which makes 6. So we start with 80. Sorry if that was not enough time. We just got lots to do. That's all. So 80, what's the smallest number to go in 80? 2, and it goes in.
40.
Smallest number to goes into 40,
2.
and it goes in.
20.
Smallest number to go to 20,
2.
and it goes in.
10.
Smallest number to go to 10,
2.
and it goes in.
5.
So then we have 2 groups. So what number goes on the outside? 4. Square root of 5. Perfection. And then the next one, we start at 32. Sorry, I'm trying to pick a color. 32. So what's the smallest number to go to 32?
2.
2, and it goes in.
16.
So do you want to know a trick? Is 16 a perfect square?
Yes.
So here's like a little, you don't have to do this, but you are honor students, so if you catch on, then this would save you time. So all of this, you're saying 80 is 2 times 2 times 2 times 2 times 5. Okay, that's what this is. This is prime factorization. 2 times 16 is 32. We agree?
Yes.
Okay, so there's already 2 on the outside, so we're going to ignore it for a second. That means in the inside, this is the same thing as 2 times 16, right? 16 is a perfect square. What's the square root of 16?
4.
4. So a 4 would come out. Am I right? Yeah. What's 2 times 4? 8. So 8, square root of the 2 would be left under. So you got the same answer. What you could keep doing, like, did you get a square root of 2? So what if you had kept going? If you had kept going, you'd get 2, 2, 2, 2, and then you'd have these groups of 2 and this group of 2. So 2 and 2 make 4. There was already 2 on the outside, and this 2 would be left under. I know it's a lot of 2's. What I'm saying is, if you see that when you do this, there was a 2 into 16. 16 is a perfect square. The square root of 16 is 4, so you could automatically pull that out. Like, you can keep doing the prime factorization, but you could also know that it's a perfect square. Does that make sense? Mm-hmm. So, like, when I do things, I'll show one more example. So when I do something like the square root of 45, I think of perfect squares that are a factor of 45. Factor means 2 numbers that multiply to 45. So me personally, I think of 9 times 5, because 9 is perfect square. What's the square root of 9? 3. And then square root of 5. Things like that. So like if you know the perfect squares, and it's fine if you don't, but perfect squares are 1, 4, 9, 16, 25, things like that, then you could, it's an easy shortcut. You don't have to, again, but if it's something you want to practice, this is what I do. But that's what we're doing with that. We're done with those.